Hi, this is Tony Northrup for TrainSignal, and in this video lesson, we're going to learn how to control access to local hardware and applications in Windows 8. This maps to Objective 2.4 of the Microsoft 70-687 certification exam, and their official objectives have 4 sub-objectives. The first is to configure AppLocker, which is a technology that gives you complete control over which apps can run on any computer in your organization. The second sub-objective is configure access through group policy and local security policy. When they say configure access, they're talking about hardware access, like which printers people can run or which other devices people are allowed to connect to their computer. For example, you could prevent people from connecting webcams to their computers if you wanted to. The third sub-objective, manage installation of removable devices. That's really talking about flash drives. So a lot of times people will take a flash drive and connect it to their computer so they can bring some work home with them. The downside of that is it could be a confidential document, and you could have all these firewall rules set up to control access to your network. But if you give people the ability to copy files to a flash drive, all goes out the window as soon as they drop it in the parking lot and somebody else finds it. So a lot of organizations want to shut down those removable flash drives and just get some control over it. I'm going to show you exactly how to do that. Up first, we're going to walk through configuring AppLocker using group policy settings. This is my Windows Server 2012 domain controller, and I'm editing the group policy, which will apply to all the Windows 8 client computers in the organization. Now, AppLocker can actually apply to earlier versions of Windows as well. We'll show you how to configure both desktop apps, which run in earlier versions of Windows, and the new Metro-style apps, which can run on Windows 8 PCs. So within the group policy, I'll expand computer configuration policies, Windows settings, and then application control policies. In that you see AppLocker, and when I expand that you see 4 different types of rules. Executable rules, which are desktop apps. Windows installer rules, which allow you to control Windows installer packages, the MSI files that install apps on PCs. So basically you can say only certain apps can be installed, whereas executable rules say only specific executable files can be run. Script rules give you control over which scripts can run. Now, a script is just a text file that has a bunch of commands that a computer can run, so it's kind of a primitive ad hoc application. And finally, packaged app rules. These are Windows 8 AppX packages, what they call Windows Store apps or Metro apps. So let's start with the executable rules. These are the rules that you'll create to configure which apps can run on Windows 7 and earlier versions of Windows, as well as which apps can run in the Windows 8 desktop. And the first thing you always want to do is to right-click that and then click Create Default Rules. Now here you can see it created 3 default rules for me. And if you look at these rules, you'll see they basically allow people to run whatever apps they want. This shows allow user everyone to run all files located in the Program Files folder, as well as all files located in the Windows folder, and then it allows administrators to run files located anywhere on the PC. So these 3 default rules allow administrators to run anything they want, anywhere. Anybody who's not an administrator can still run Notepad and other things that are located in the Windows folder, or files that are located in their Program Files folder. This already is pretty useful because it's preventing regular users from running apps that they might download from their Downloads folder. Because the Program Files folder and the Windows folder have restricted access, standard users can't save files to them. Therefore, a standard user cannot download an executable and then run it because they can't even copy it to a folder where they would be allowed to run it. Now let's create a new rule for an executable file. The Create Executable Rules wizard just walks you through the process. The permission page here lets you choose whether you're going to allow or deny a specific app. Now, if you allow an app, the users will be able to run it from anywhere. If there's an app you specifically want to block access to, select Deny here, and then you'll select it on a later page. This action represents very different philosophies. You can choose either to block everything and then allow specific apps, or allow everything and deny specific apps. I'll say that this approach is much more secure, blocking everything and then allowing the apps that you choose. If you try to deny specific apps, say specific malware apps or apps that you might think might distract the users like Minecraft, Well, you're never going to get everything because a new version of Minecraft will come out or somebody will modify the file so that your computer won't recognize it. People will easily be able to work around it. If you choose to block everything and then allow specific apps, you have to go through and pick every app that you want your users to be able to run. And it's not as easy as it might sound because many apps launch other smaller apps that you never even notice are running. So it requires a lot of administrators. Basically, AppLocker, especially for desktop apps, is really pretty hard to implement. It could easily be somebody's full-time job in an enterprise organization just chasing down every app that people can run. And if you go with the block everything and allow just exceptions rule, well, guess what's going to happen? Some CEO is going to need to run some app in an emergency and they're going to find that it's blocked and they're going to blow their lid. They're going to be so upset because they're not going to be able to run their app and maybe it'll ruin their meeting and cost them an expensive deal. So you take a risk when you block everything and allow specific things. You take the risk that somebody at some point is going to lose productivity because they won't be able to run a legitimate app that they need. So think about those two approaches as you go forward. Now, at this point, you can choose different ways to recognize the executable file that you're going to run. The first is publisher. Apps are usually signed by the publisher using a certificate. Any app that the publisher makes is going to have that same certificate signed, so you can choose to acknowledge that publisher certificate, and then anything they make, the users will be able to run. Path is a pretty useless rule. Path allows you to specify either a file name or a folder, and Windows will run anything with that file name or anything contained in that folder. As you can imagine, that's really easy to circumvent. If you allow notepad.exe to run, users could simply rename Minecraft to notepad.exe and then they could run Minecraft just because it was renamed. So it's really easy to circumvent. File hash is a little more secure, but it's also kind of a pain. File hash creates a hash of an executable file. A hash is a unique representation of that file. And it's very effective at identifying one specific executable. But the next time the developer releases an update and they change the bits in that file a little bit, the file hash is going to be different. So you have to go back and update your rule to allow the new version of it to run. So using file hashes is effective, but it can be a real pain. Now, I chose to do a file hash here, so I need to browse for the file that I want to allow. I'll just pull the write application from the Windows folder, and we'll use that as an example. So because I opened up the file, it's going to calculate the hash of that file. And then after I make this rule, any computer who wants to run any executable file, regardless of the name or the publisher, as long as it has the same matching hash as this file, it'll run okay. And because hashes are an effective way of representing a unique file, only the exact same file will be able to run. And this just allows you to identify the rule. So I'll create another rule for an executable file just to show a different path. Now we'll create a publisher rule. And I'll also select write.exe for this. As you recall, the publisher rules identify a specific developer and allow me to configure which apps from that developer I can run. Now, I opened up the write.exe app, and doesn't mean that users will only be able to run write.exe. I have control over which aspects of this app are used to create the rule. So you can see the wizard examined write.exe and pulled out 4 pieces of information from the file's metadata. The publisher, which is Microsoft Corporation, the name of the product, it's part of Windows, the file name, which is write, and the version. So this slider controls which of these rules take effect. If I put it here, this rule will mean anything from Microsoft is allowed to run. Not a bad rule to make. If I put it here, it means that anything from Microsoft having this exact product name will run. If I pull it here, then these 2 rules apply, plus the rule will be limited to apps with the file name of write. So a new version of write comes out, it would still run. An old version of write, it would still run. A legitimate Microsoft app that was renamed to write, it'll run too. And this specifies the file version. You would want to leave it here if you wanted to test each new version of the Write app that came out. This particular rule would only allow users to run Write version 6.2. If you want to make sure that people can run a new edition of Write after it comes out, you could leave it up here and leave an asterisk for the file version. Notice the Use Custom Values checkbox here. This allows you to modify these things. So, for example, if I wanted to allow the current version of Write to run as well as any later versions, I just select that and select End Above. And here on the Exceptions tab, imagine that for the publisher rules, I simply allowed everything from Microsoft to run. If I wanted to prevent a specific app that was signed by Microsoft from running, I would create an exception. So we'll pick this app. So now, because of the publish rule, any app from Microsoft will run, except for that one specific app that I selected. So I'll create that rule too. Now, if you decide that you want to block everything except the rules that you allow, you need to change these default rules, because as you recall, when we created the default rules, they allowed everybody to run everything in specific folders. If you decide that you want to create rules that allow specific apps and block everything by default, you need to go in and modify these default rules. All you have to do is open them up and select Deny. And then again, you need to manually go in and create allow rules for everything that you do want to work. That's a lot of work. It's going to take a lot of testing. Now, before we go further, I want to show you the rule enforcement for AppLocker. By selecting the AppLocker node here in Group Policy, you can configure the rule enforcement. Until you do this, nothing takes effect. So I just made some rules, and now I would want to go in and select this checkbox to configure the executable rules to take effect. You'll see that this list gives me two options: enforce rules, which makes the rules take effect and would block apps that weren't specifically allowed from running, and audit only. Audit simply adds an event to the security event log if one of the rules is broken. So if you were to create the rules that I made and only allow users to run that Write app and selected audit only here, I would get an event in the event log every time somebody tried to run another app. This is really, really useful. What you want to do is create your rules, and instead of immediately setting them to enforce rules, you'll set them to audit only, and then you let users go about their business. You need to go on the computers and check the security log and see the list of events that indicate which apps they tried to run that failed, because each one of those legitimate apps would have been a point of frustration for the user. So look at all these audit failures and then go back and determine which ones the user should be allowed to run and add more rules to them. Keep doing this until all the audit exceptions are for apps that you don't want the user to run. Otherwise, they'll get frustrated. So let's look at creating an AppLocker rule for a Windows 8 app. First, I'll generate the default rules. Now I will create a new rule for my own custom app. I want to allow this side-loaded app. So here you have two choices. You can click select here to select an app that's already installed, or if you have access to the AppX package, select use a packaged app installer as a reference and then click browse. In the software folder here, I have a custom app that I created with Visual Studio, just like you would in an enterprise environment. And you can see it's signed by me with my certificate. And as with the executable rules, I can select different levels of criteria. So let's say I want to allow any version of this particular package to run. Now, if you recall, in the desktop rules, it was simply allowing me to specify a file name. These AppX packages are way more sophisticated and they give you much tighter control. So here the package name is this long series of letters and numbers that uniquely identifies it. That's much harder to fake than a file name. In fact, AppX packages were designed for making effective AppLocker rules. So you'll find that as far as Windows 8 goes, it's much, much easier to control which apps users can run and can't. Basically, you just need to go through and pick the packages that you want, and it will work much cleaner. As before, you can select exceptions here if you allowed all apps from a particular publisher to run. So now you know how to take complete control of the apps that your users can run in an organization, whether they're desktop apps or Windows 8 apps. You control freaks are going to love this. You can control the hardware that your users can connect to their computer, which means if you don't want them to connect particular types of headphones, or if you don't want them to use webcams, you can prevent that access. Like most things Windows 8 in an enterprise, you're going to configure it using group policy. So let's dig into the group policy that we need to configure. You'll find it under Policies, Administrative Templates, System, and then Device Installation. Select Device Installation Restrictions here. Now you see a bunch of different policies, and probably the most important one is this last one here, prevent installation of devices not described by other policies. As I discussed in AppLocker, you have two different approaches to security. One is block everything except what I specifically allow, and the other is allow everything except what I specifically deny. If you allow everything by default, it's pretty easy for users to work around. And if you block everything by default, you'll definitely end up accidentally inconveniencing users at times. And you'll also take on this massive workload of determining everything every user in the organization might ever want. So the first thing you want to do, if you decide to block everything by default, is to prevent the installation of devices not described by other policies by enabling that policy. If you are taking that approach, you'll want to edit this policy, allow installation of devices that match any of these device IDs. So we'll enable it, and you can see they provide some examples here of the types of IDs that you might want to put in. You'll specify them by clicking the Show button here. Now, different types of devices have different types of hardware IDs. This is going to be something that you'll simply have to search for, but they provide a couple of examples, so we use one of these. I'll just type in GenDisk, and then we'll click OK. And that's all it takes. With those two policies configured, no user in my organization would be able to connect any sort of hardware except that GenDisk that I specified. Now, you're going to want to do a lot of testing. Set up your own private test environment and make sure that every piece of hardware they absolutely need is configured. Otherwise, you're going to end up with some really frustrated users and probably lost productivity. Now, let's say you're taking the other approach where you simply want to block specific devices. In that case, you'll want to edit this policy. Prevent installation of devices that match any of these device IDs. This works exactly the same way. Enable it, click Show, and then type the device IDs that you want to block. Now, those are the two most useful policies. Specifying the device IDs blocks an entire class of devices. If there's a particular model that you want to allow or prevent, use the allow installation of drivers that match these device setup classes. When you enable this and click Show, you need to specify an entire GUID. Again, this is best found by doing a quick Google search. So I did a search for this, and you can see if you wanted to block all Bluetooth devices, well, here's an example GUID that they provide. All Bluetooth devices will have this particular GUID, and indeed there are GUIDs for different class devices. And indeed there are GUIDs for just about every type of device class that you can imagine. So I can paste that GUID in here, and because this is the allow variety of that policy, all Bluetooth devices would be allowed. The opposite of that is the prevent installation of devices using drivers that match these device setup classes. Again, that's if you go with the allow all and block everything I specifically list. That's mostly all there is to it. There are a couple other policies here that are really useful. This particular policy, display a custom message when installation is prevented by a policy setting. This is something you should enable, and you would say something like, please contact your system administrator to resolve this particular problem, or standard users are not allowed to install Bluetooth devices because of security concerns. Just give them some explanation so they get a useful error message and a path to resolve the problem by contacting you or someone in IT. Another related policy just controls the title of the message that's displayed. Now you're ready for the last sub-objective in this lesson, which is to manage removable devices. This is really closely related. Now, these removable devices are everything from old floppy drives to CDs, or more likely USB flash drives now in the modern era. As I was saying earlier, people often copy confidential documents to these USB flash drives, and then you completely lose control of it. You can't audit it. You don't know where it ends up. Can be really easy to lose too. So it's really important to manage these things. Removable drives are also a way that malware gets spread, because somebody could connect a flash drive to their home PC, and that home PC, if it's infected with malware, it might copy the malware to that flash drive. They might bring it into your organization and accidentally install it on their PC. So flash drives are also a way that malware gets copied around, but we can fix that really easily. Jumping back to my group policy editor here, you can see I've pulled up the policies. Just like the last policy, it's under Computer Configuration, Policies, Administrative Templates, System, and then down a little bit farther, Removable Storage Access. In this policy group, you see a whole list of policies that give you complete control over the removable storage that people can use. So you can see these policies here control whether they can execute files stored on CDs and DVDs, read files on CDs and DVDs, or write files on CDs and DVDs. So if you're worried about people spreading malware or installing software from a CD or DVD, enable this policy. If you still want people to be able to put in a CD and copy files from it but not run an application, then you should disable read access from CDs. Now, this is a little tricky, but I'm disabling a policy that says deny read access. So if I were to enable it, I would be denying read access. But by disabling it, I'm actually allowing read access. If it's not configured, then it's the same as being disabled. So I don't necessarily need to disable it, but I can disable it to override other policies in the organization. Now, there's something tricky here. I denied execute access, but I allowed read access. So what people can do is they could copy the file from the CD to their local computer, and then they might be able to run the application from the local computer. So be careful with that. Anytime you allow read access, it's possible for somebody to get an executable file from it, but it would be more difficult. And the third policy relating to CDs and DVDs is to deny write access. You would want to enable this policy if you didn't want people to take confidential documents out using removable drives. Now, I used the CD and DVD policies as an example, but you'll see there are other policies for floppy drives, tape drives, and removable drives. These removable drives are the USB flash drives that are most commonly used, including both hard drives and USB flash drives. If in the future they invent some other sort of removable drive, you can use these custom class policies and then specify the GUIDs here. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.